Psychometrics is the science of measuring mental capacities and processes. This involves the assignment of scores to individuals so that the scores represent some characteristic of that individual. This requires the systematic assigning of scores to individuals or objects so that the score represents the characteristic of interest. Now, exactly how you go about measuring these mental capacities and processes really does depend on what it is you're trying to measure, what those variables are. Now, researchers are typically interested in specific factors, or you could call them variables, and how they're affected under various conditions, or how a variable differs from one group to the next. And though we measure all kinds of variables every single day, things from temperature to time to how many soda cans you still have in the fridge and so on, the process of measuring variables can sometimes be very complicated. So just to give you an example, for my research methods class, I needed to measure a certain number of variables. The first thing I needed to determine was exactly what the variables were. So, like for example, I want to measure if my students are learning anything in my class. What I'd like to do is just ask the student to tell me if they've, learned anything, and if I feel like they have sufficiently learned, then they get a pass for the class. But obviously, that's not going to work out. That's not the norm for our educational system. So instead, I needed to think about this in a more scientific way. I needed to try to quantify this concept of learning. And there's a few decisions I had to make in order to do that. So first of all, I tried to break it down into individual variables that are important when it comes to learning. The first one is comprehension. So I wanted to see how well my students are understanding the course material. And in order to measure comprehension, I started to think about different ways I could, craft assignments, like maybe short answer or essay style questions. This would be a good way to measure comprehension because students can't simply just repeat what they have read. They have to actually form it into a thought. They have to, put it in their own words. But as is the case with any variable that you're trying to measure, there's a lot of problems you're going to have to resolve. There's a lot of concerns that you're going to have to deal with before you can commit to that plan of action. Similarly, I also wanted to measure how well my students can not only learn this material, but how they can actually apply it in a real world situation. And in order to measure application, the most obvious way to do that for a class like research methods is to do research, to write up a scientific research report, which would include developing a method and collecting and analyzing data and going over all the other aspects of the course. But that has its own concerns that would have to be dealt with. And then also, it's not good enough to simply learn the material. I also want to make sure that my students are actually remembering this material. I want to measure that retention of information over time. And one of the classic ways of measuring retention is to give students periodic tests or quizzes. Now, there's tons of different ways you could do a quiz or a test, but I find that multiple choice questions are not only preferred by students, but are also a fairly accurate assessment of memory, and they're pretty easy to grade. So those are just a few examples of what I'm talking about when I talk about these variables, these factors, and ways that we need to try to measure them. It definitely does require a lot of decision making, because oftentimes when it comes to trying to measure these kinds of things, there's no standard way to do it. It's really up to you how you decide to go about measuring it. But the thing is, even if you come up with the best possible method for measuring those variables, that doesn't mean it's perfect. There's always a chance that your variables are going to be influenced by other factors, factors that you aren't at all interested in. Like in my examples, I'm trying to measure how much my students are learning, but it is very well known that a student's performance on a homework assignment or a quiz or a research paper or anything else in the course is not simply influenced by what they've learned. It's also influenced by their state of mind, by their home life, by their income. There's tons and tons of things out there that play a role in that, measurement. So you need to try to keep that in mind when you are going out to measure these kinds of abstract concepts like learning. But not all variables are so hard to measure. Sometimes when you go out there and you do some research, you'll find that we do have standards for measuring these variables. Like we have well-defined measurement instruments to indicate exactly how to collect the data in the most accurate way. Some obvious examples would be things like height. Everybody knows how to measure height. You use a ruler of some kind of measuring stick, either in centimeters or inches or whatever. Another thing that's fairly well established is the measurement of weight or volume or money. But these are not the things that most psychologists are interested in. These things are great in many fields of science, but in psychology, we're typically more interested in things that are a bit more difficult to measure. Things like learning, or intelligence, or personality, or motivation. So this just makes our measurement methods a bit more complicated. But there's a reason for this. We measure these kinds of things because they're interesting. People just naturally seem to assume that these kinds of abstract qualities exist, and if we could develop a way to measure them, then we would have a good way of learning about people and quantifying people's abilities. In fact, a lot of these concepts are central to our understanding of the world. We talk about things like hunger, happiness, intelligence, honesty, friendliness, race, emotion, self-esteem, love. Like, we just take these things for granted, but exactly how we should approach them as scientists is not so well established. But we have approached them, we have tried to develop standards, and those standards are constantly evolving and becoming more accurate. These standards, these things that we're interested in, we call them constructs, or hypothetical constructs. These are these hypothetical attributes or mechanisms that help us to explain and predict behavior in a theory. Now, these constructs, when I say that they're hypothetical, what I mean is they're abstractions. They're things that don't physically exist in the way that we talk about them. You cannot observe them directly, but we assume they exist. We assume they exist because we see the consequences of these things. When we see somebody do something stupid, we say, oh, that person is not intelligent. What I'm saying here is we associate that behavior we saw with something that is invisible, something that is intangible, this concept, this construct that we call intelligence. But another example, something that a lot of people don't talk about enough, is the construct of race. Race is a social construct, which has had numerous definitions throughout history. How we go about measuring a person's race has changed dramatically based on the times and the needs of the people. Like, throughout history, skin color has been a major factor in determining race. So people might even have like a color swatch that they'll hold up to your skin to try to define what your race is. If that sounds silly, well, it is, but that's what people used to do in the past. Other common features that they would look at are like facial features, like the shape of your nose, the shape of your mouth, and your eyes, and things like that. That's also been a fairly important factor. In fact, back not too long ago, just about 60 years or so, I'm not a big history person, but I know they were doing this a lot during Nazi Germany times. They would actually determine who was and who was not Jewish by measuring like the shape and the width of their nose and things like that. So these things have some real serious consequences. If your fate depends on something so superficial like that, it's important that we understand what we're even measuring here. Obviously, all they were measuring is a nose in that particular case, but it has some obvious, like serious consequences. So we want to make sure that our measurements of these constructs are accurate. And we didn't really use good science back then, clearly, but as we go forward, we're trying to develop these ways of measuring constructs that are very well supported and do accurately measure these constructs of interest. For example, we have the Big Five. We've done a lot of research into personality, and we've developed these 5 constructs of personality that have been very well supported. So, according to the theory, personality consists of these 5 different traits, and we have developed extensive methods to measure each one of them in detail. So they are openness to experience, conscientiousness, extroversion, agreeableness, and neuroticism. But that's just one example. There are numerous examples of constructs that we have well defined. But before you can figure out exactly how you want to go about measuring such a thing like personality or intelligence or race, first you need to just explain what it is. You need to create what we call a conceptual definition, a description of the behaviors and internal processes that make up a construct, along with how it relates to other variables. Now, conceptual definitions, this is important. Conceptual definitions do not provide a detailed procedure for measuring a construct. So a conceptual definition is just like a description, like what is this thing even? You know, we don't really know how to measure it based on this, but we can talk about it and we can understand what it is. That's the whole point of a conceptual definition. When it comes to actually measuring a variable, you'll need to develop a different kind of definition that we call an operational definition. So this is the definition of a variable in terms of precisely how it is to be measured. So this will specify a measurement procedure for some external observable behavior. So if we go back to that example I mentioned of intelligence, you know, if somebody does something stupid and we say, oh, that person doesn't have a good intelligence, or they have a low intelligence, we're creating an operational definition there. We're saying, if you do these kinds of things, then that will allow us to measure your intelligence. That's exactly what operational definition is. It's when we say these behaviors are associated with that thing that we can't really measure directly. So those resulting measurements are used as like a definition and a measurement of the construct. And there's 3 different kinds of behavior that you can look at when it comes to operationally defining a construct. You can look at self-report measures, behavioral measures, and physiological measures. So the first one, the self-report measures, this is a measurement obtained by simply asking the participant to describe his or her own attitude, opinion, or behavior. In other words, the behavior we're associating with the construct is just the person's opinions, the person's feelings. We just ask the person, like, how smart do you think you are on a scale of 1 to 10? So this has some benefits and some drawbacks. It provides a direct measure. You know, the participant is directly providing you with information, with their insight into their own attributes. But the drawback is that the validity is a bit dubious. You know, participants need to be both honest with you and themselves, and they also need to be self-aware. But there's actually a third quality that's also very important, and that would be the ability to communicate. So what I'm saying here is participants They need to be able to accurately and honestly understand who they are and then communicate that to you. So self-report is not going to work for many kinds of individuals. Individuals who are either very young, individuals who are very old, or individuals who just cannot communicate very effectively for one of many reasons. And you can do this kind of self-report measurement in the form of either like a survey, like an internet survey, pencil and paper survey, or you could just do an interview. That's basically what an interview is. An interview is just like an in-person survey. So regardless of which method you choose, it's still just a self-report. You're just asking the person questions about themselves. The next method of measuring variables, assessing constructs with the operational definition, would be by taking behavioral measurements. And this is where it starts to get a lot more, interesting in my opinion, because now we're not going to have to worry about the person's feelings and opinions. We're just going to be looking directly at their behavior. So with a behavioral measurement, we are directly observing an individual's behavior and measuring that behavior all according to some previously determined rules. Now, behavioral measures are based on only overt behaviors, so things that you can, see and things you can directly measure. And when it comes to measuring these kinds of things, researchers do have a vast number of options. Like, we get to decide what kinds of things we want to look at, how we're going to measure them. Oftentimes this will involve, recruiting many different observers to all try to provide the same data to see if, there's some agreement between them there. But the whole idea here is that the behaviors are thought to be just a sign of something underlying. Those behaviors are just, the consequence of that, driving force, that construct. And exactly what kind of behaviors to measure and how to measure them has been the subject of debate throughout the history of psychology. We had people like B.F. Skinner who would study things like learning and how that can be shaped over time through, constant observation, recording the frequency of various behaviors and so on. Then you have other more modern research using techniques such as transcranial direct current stimulation, where small weak electrical charges pass through the brain and the individual's performance on some task is measured as a consequence of that electricity. Then you have other researchers like Harlow, who looked at relationships and what infants need from their interactions with caregivers, and studies of things like learned helplessness, where dogs attempt to escape from a painful electrical shock was measured and recorded over time. So these are just a few examples, but there's definitely a lot of diversity out there as to how you could go about measuring different kinds of behavior to try to assess those underlying constructs. But there's a special subgroup of the behavioral measurements that I just briefly wanted to mention called psychophysics. Psychophysics specifically looks at the study of a relationship between physical stimuli and the perceptions they evoke. So in this case, the person's decisions based on the physical stimuli would be the behavior, and the construct would be the perception that they evoke, because we can't tell what a person is seeing or hearing or smelling or anything like that, but we can assess what they are perceiving based on the decisions they make on that perception. So oftentimes when it comes to psychophysics, we'll measure things like a person's ability to recognize a stimulus quickly or respond appropriately. There have been a lot of studies on things such as pain tolerance, which is a highly perceptual experience. What might be very painful for one individual could be relatively minor for another. So there's been a lot of really neat research from this field. But if you don't want to look at a person's behavior and you don't want to talk to that person because you think these aren't direct enough, you want to get as close to the person's behavior as possible, as close to that construct as possible, then your decision should be to use physiological measures. So these are measurements that are obtained by recording physiological activity, such as heart rate or breathing or brain activity. And as I said, this is what you should use if you want to get to a more direct way of assessing that construct. This will provide a much more objective measurement, but typically does require more expensive equipment and more, extensive training in order to be able to perform adequately. Now, the only real drawback to using physiological measurements is that they might be too direct. They might be too close to the individual when it comes to the behaviors, because they might measure something important about that construct, but it's probably not all there is to that construct. It's, to put it in a sense, it's kind of like you're looking too close. You're examining this construct under a magnifying glass that's just too powerful, and you're kind of missing the big picture. There's a lot that goes into any construct in psychology, even the most simple ones. So if all you look at is something like heart rate, you're probably missing out on a lot of what makes that construct special. But yeah, a lot of different physiological measures are used quite frequently in psychology, such as electroencephalogram, electromyogram, electrooculogram, functional magnetic resonance imaging, and positron emission tomography, just to name a few. But at the end of the day, no matter what kind of method you use, no matter what operational definition you have for the construct you're interested in, it's probably going to give us some interesting data. And when we get data about a construct using many different operational definitions, so when there's many different operational definitions all measuring a single construct, that is actually exceptionally helpful. That gives us a more complete picture of what that construct is and the best way to go about assessing it. This is what we call the convergence of operations. Like a polygraph machine, for example. I'm sure you've heard of like a lie detector test. This measures many things, and all those different behavioral measurements that it looks at. This doesn't just look at behavioral measurements, it also looks at I meant physiological. It doesn't just look at physiological measurements, it also looks at some behavioral stuff too. And all those different measurements combined give us a very accurate assessment of the person's, underlying behavior. Obviously, lie detector tests, they don't actually measure truth. What they measure is your emotionality. And the whole idea here is if you start to act a little fearful, then you're probably not telling the truth. But by combining all these different measurements, we can get a very clear image as to exactly what your emotional state is at the time you're giving some testimony. So it can be very, very helpful to measure a construct using all these different methods simultaneously in some cases. But when we do that, when we measure the same thing using different definitions, different operational definitions, there does run a risk. It can lead to what we call desynchrony. This is when your various measurements don't match. Like there's a lack of agreement. Like, let's say in a polygraph test, we measure your heart rate and other, like galvanic skin response, for example, other things too. And the heart rate indicates that you're perfectly calm. But all the other measurements indicate that you're freaking out. So which one is important? How do we resolve this kind of desynchrony? Well, it's up to you as the researcher to make that decision. But what is commonly done in these cases where we have converging operations and one or more of them are desynchronous is either they'll go with the average score across all the different measurements, or they'll just add them all up and you'll get a total score. So in that case, if half of the measurements indicate that you're lying and half of the measurements indicate you're not lying, it would balance out to 0, indicating you're probably not lying. But that's just one example. There's tons of different ways to resolve these kinds of issues when it comes to measuring constructs using operational definitions. But one common issue that researchers will face when it comes to measuring any construct is doing so with the appropriate scale. They want to measure it using what we call sufficient sensitivity. So just think of it this way. If you were to measure a human's weight, you could use a bathroom scale, right? Like if you want to see how heavy a human is, you put him on a bathroom scale. But if you have a pet hamster, that bathroom scale is not going to work out. That you're not using you're not using the correct scale of units. You would want to use a smaller scale in that case. And if you're going to measure an elephant, you would want a much, physically larger scale to get a more accurate measurement. So you need to make sure that the measurements you're taking are scaled appropriately. I keep saying scale. You understand what I'm saying. But if you don't do this properly, then you are going to suffer from what we call range effects. So range effects refers to the clustering of scores at one end of a measurement scale. So there's two kinds. You have what we call ceiling effects. So that's when the scores cluster at the high end. As you can see in the top chart here, the scores seem to be going up in a kind of linear fashion from the bottom left to the top right, but then they hit the ceiling and they just flatten out. So you have to imagine in that case that if they could continue going up, it would probably continue going straight in that kind of diagonal line. But we have a ceiling, we have a maximum value that they're bumping up against, and we don't see that kind of trend that we might expect. And then the other kind of range problem would be called a floor effect. So that's when the scores cluster at the low end of a measurement scale, as you can see in the bottom example. So clearly, if the scores could get any lower than that bottom part of the chart, then we would expect it to continue that similar kind of downward diagonal trend. Like if these are examples of problems, maybe this is what the data would actually look like if we didn't have such range effects. So you can see how choosing the appropriate scale can be a huge deal. You want to make sure you're getting the most accurate measurement of your data that you could possibly get. Now, so clearly a lot goes into creating a good operational definition, and some are much better than others, but there's a few important things to keep in mind. An operational definition is just a description of how you're going to measure a thing. It is not the thing that you're measuring. Like a conceptual definition, that's a description of what a thing is, right? But operational definition, it's more so just like a set of instructions. It's like, here's how to measure this thing. I think you understand what I'm trying to say. So operational definitions, that's just instructions for measuring. Conceptual definitions, that's the actual explanation of what that thing is in the first place. So you want to make sure that both kinds of definitions are accurate. You want to make sure that you know exactly what you're talking about by having a good conceptual definition, and you want to make sure that you're measuring it as accurately as possible by having a good operational definition. And the best way to do that is to simply create like a new operational definition, and see if it is in line with what we've already done. Now, most constructs in psychology have been studied pretty extensively by now, and we have developed some pretty good operational definitions. So if your new idea, if your new definition can help, if it corresponds with the stuff we already know, then we can decide that it's probably a good one. But if your new definition conflicts, if it gives different results than the previous stuff, then it's probably a bad definition. So all I'm saying here is the same thing I've said in previous videos. Science is a thing about just taking little steps. We're getting closer and closer to the truth. So if you help us to get a little bit closer to the most accurate measurement of a definition by providing something that corresponds with what's come before, but maybe is a little bit more accurate, then that's exactly what we would want. That's exactly what we would expect. But if your operational definition gives us something completely different from what's come before, then you're probably going off in the wrong direction. You're probably going to be giving us bad data. And that's exactly what we want to try to avoid.